Liftoff.
Allumage UAP, décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
The James Webb Telescope found something mysterious on its recent mission, and we might have just found proof of alien existence. The world's most powerful telescope was pointed towards the Kuiper Belt, home of the former planet Pluto. Scientists had just hoped to make a few observations and take pictures for further analysis until they saw weird movements happening on the planet. This caused them to examine the weird phenomenon closely, and what they saw blew their minds. What did scientists and astronomers see? Could this bizarre phenomenon be why Pluto was declassified as a planet? Join us as we explore how the James Webb Telescope just detected a huge miles-long structure moving on Pluto's surface. The James Webb Telescope went on a mission with the New Horizons probe to investigate Pluto's surface, and scientists were puzzled at the content in the image it sent back.
One of the most exotic surfaces on Pluto is Sputnik Planum. Big, white area, expanse of ice.
This image featured a mysterious object appearing to slide through the surface. Although the space agency tried to debunk this discovery, ufologists and alien theorists would not have it, as they wanted to learn more about this moving structure. This image, currently stirring the entire world of science and astronomy, was captured by the James Webb Telescope and was transmitted from the Long-Range Reconnaissance Imager. This image extended the JWST's and New Horizons' highest resolution views of Pluto to the center of the Sputnik Planum. This indifferently named icy plain forms the left part of Pluto's heart feature. And although Sputnik Planum is at a lower elevation than most surrounding areas, it isn't entirely flat. Its surface is divided into polygons or cells 16 to 40 kilometers wide. And when viewed at low sun angles, it's a different case. If viewed with visible shadows, the cells would seem to have somewhat raised centers and ridged margins, with about 100 meters of overall height variation. Several researchers believe the cell's pattern comes from the slow thermal convection of the nitrogen-dominated ices that cover Sputnik Planum. In a reservoir that's possibly multiple kilometers or miles deep in some areas, the solid nitrogen is warmed at depth by Pluto's moderate internal heat. As a result, it becomes buoyant, develops into great blobs, and then cools off and sinks again to restart the process. William McKinnon, deputy lead of the New Horizons Geology, Geophysics, and Imaging team from Washington University, commented on this phenomenon. He said, "This part of Pluto is acting like a lava lamp. You can imagine a lava lamp as wide as and even deeper than the Hudson Bay." Computer models by the James Webb Telescope team depict that these blobs of overturning solid nitrogen can slowly change and integrate over millions of years. The rigid margins signify areas where cool nitrogen ice goes back down, after which it can be pinched off and abandoned. And there is a possibility that the X feature is one of these, as it's a previous quadruple junction where 4 convection cells cross paths. In fact, multiple active triple junctions can be seen elsewhere in the mosaic. In the James Webb Telescope observing area, Pluto's informally named Viking Terror area was also shown in the combined data. It was pictured from a whopping distance of almost 49,000 kilometers while displaying features as small as 480 kilometers across. And while these pictures taken by the JWST were analyzed, another phenomenon caught the eyes of scientists and researchers. They discovered bright methane ice that condensed on many crater rims. These are a body of dark red tholins. They are small soot-like particles formed from reactions involving nitrogen and methane in the atmosphere in lower areas. They're mostly found on the bottoms of craters, crater walls, and the layering of the faces of steep cliffs. Scientists also saw that in regions where the surface looks smooth and the reddish material is thicker than usual, then there is a high chance the material has flowed into some craters and channels. Scientists often theorize that tholin deposits of that thickness aren't usually mobile on large scales, meaning they could ride along with ice flowing beneath or blown around by Pluto's winds. And these images provided by the JWST have shown that it's the latest to show strange pits on Pluto's heart. The fact that these images were revealed by the James Webb Telescope in extraordinary detail, along with color images of the dwarf planet's Badlands, gave the scientists more zeal to research more. This extensive research found that mission scientists now believe these strange craters may form through ice fracturing and evaporation. The scarcity of overlying impact craters in this area also makes scientists assume that these pits formed relatively recently and are hundreds of yards across and tens of yards deep. Their alignment provides insights into the ice flow and nitrogen exchange with other volatile materials between the atmosphere and surface. When scientists and researchers kept on with their observations sent by the James Webb Telescope, they saw that Pluto's landscape was far more varied than scientists could have imagined. The latest high-resolution images of the dwarf planet show this diversity in unprecedented detail, highlighting what happens to be snakeskin-like patterns on its surface. The clearest image of this was taken near the line that separates day from night, capturing a vast rippling landscape of strange, aligned linear ridges, the NASA said, astonished New Horizons team members. It's a unique and perplexing landscape stretching over hundreds of miles, said William McKinnon, New Horizons Geology, Geophysics and Imaging Team Deputy Lead from Washington University in St. Louis. It looks more like tree bark or dragon scales than geology. This'll really take time to figure out. Maybe it's some combination of internal tectonic forces and ice sublimation driven by Pluto's faint sunlight. Scientists aren't sure what caused the pattern, but theories include the impact of plate tectonics rippling the surface or frozen gases released when surface temperatures increase. But the snakeskin image of Pluto's surface is just one tantalizing piece of data New Horizons sent back recently. The spacecraft also captured the highest resolution color view yet of Pluto, as well as detailed spectral maps and other high-resolution images. The new extended color view of Pluto shows the extraordinarily rich color palette of Pluto. NASA's New Horizons probe flew by Pluto nearly 8 years ago, but the epic encounter still bears scientific fruit. New Horizons gave humanity its first up-close look at Pluto when the probe zoomed just 12,500 kilometers above the dwarf planet's frigid surface. The mission team is still analyzing the stockpile of data New Horizons gathered during the flyby and making intriguing discoveries as new results show. New Horizons researchers shared their latest findings at the Lunar and Planetary Science Conference being held in Texas and virtually. And among the discoveries presented, one tied Pluto's puzzling flip to its ice-filled base, and another found interesting but puzzling landscapes on the dwarf planet's surface, and a third unveiled the building blocks that formed the snowman-like object Arakoth, which New Horizons and the James Webb Telescope observed. While scientists knew that Pluto, like Earth, flipped on its side sometime in its past, Pluto's orientation before the flip and the degree to which it reoriented itself has not been well understood. Scientists who use New Horizons data to study Pluto's geologic past hope to find clues that explain this event. And now a group of researchers has attributed Pluto's flip to the formation of Sputnik Planitia, a 1,000-kilometer basin that makes up half of the iconic heart-shaped region on Pluto. Researchers previously knew that Sputnik, filled with nitrogen ice, played a profound role in realigning the dwarf planet's surface. But using images that New Horizons sent home from the flyby, they are now trying to trace the path of Pluto's flip. In doing so, they found parallel mountain ranges and deep valleys that form what they think is a global tectonic system. These features are more than 300 kilometers wide and span a similar distance from Pluto's North Pole. However, the fact that Pluto changed its orientation in the past reveals that none of the terrain scientists now see is in its original location. We can't really explain that in Pluto's current configuration, Oliver White, a New Horizons co-investigator at the Search for Extraterrestrial Intelligence Institute in California, said during a presentation Tuesday at LPSC. Instead, he said these features likely existed along Pluto's equator early on and migrated to their current locations near the poles because of the flip. White's team also found that Pluto's subsurface ocean likely provided some push to Sputnik and helped shift a bulk of the dwarf planet's mass toward its equator. And in addition to helping scientists study ancient landscapes on Pluto, James Webb Telescope New Horizons data provides clues about its more recent features. The spacecraft had previously spotted massive methane deposits near Pluto's equator, many as tall as Earth's skyscrapers. However, scientists said they had a new line of evidence suggesting that these knife-like landforms also extend to the far side of Pluto beyond what the James Webb Telescope and New Horizons could see during its flyby. The discovery of these features just adds to our understanding of the processes that shape Pluto and other icy planets in our solar system and highlights the complexity, dynamic nature, and diversity of planetary surfaces like Pluto's. Ishan Mishra, a postdoctoral researcher at NASA's Jet Propulsion Laboratory in California, said in a statement, "On Earth, such pillars are called penitentes. They are made of water ice and stretch for just a few meters. On Pluto, however, these features primarily exist on the highest points on its surface and soar for hundreds of meters. At such heights, methane freezes out of Pluto's wispy atmosphere in cold weather and evaporates back into its gaseous state during warmer spells." The team behind this latest study used images snapped by the Long-Range Reconnaissance Imager on board New Horizons and studied how the light reflected from surfaces changes with different viewing angles. Doing so, they found similar methane absorption features on the far side of Pluto, thanks to the surfaces being rougher than average roughness of Pluto, Mishra said during his presentation. He added that such bladed terrains are likely one of the most common landforms on Pluto. And New Horizons passed a small object in the Kuiper Belt called Arakoth, which looks like a partially flattened snowman. Located 6.6 billion kilometers from Earth, it became the farthest object ever explored by a spacecraft. It is also the most primitive thanks to its distance from the Sun, which keeps it in a deep freeze. Arakoth is a gentle fusion of two objects that once orbited each other. Scientists announced Tuesday that the larger of the two lobes, called Wenu, is a pile of 12 rocks huddled around a bigger slab. The latest findings show that Wenu formed not as a whole, but by pieces of rock already existing in the solar system's outer reaches. This is surprising and a new piece in the puzzle of how planetesimals, building blocks of the planets like Arakoth and other Kuiper Belt objects, come together. New Horizons principal investigator Alan Stern from the Southwest Research Institute in Colorado said in a statement, "In the solar system's history, millions of kilometer-sized icy objects made up a vast donut-shaped region called the Kuiper Belt at its edge." Stern said a few of them amalgamated to form Wenu, but these tiny objects did not merge at high speeds, which explains why Wenu is elongated the way it is. When objects merge at high speeds, their spin throws away material, forming circular bodies. Since the rocks have retained their shape even after merging, Stern's team estimates they would have traveled less than 1 meter per second when they coalesced. Previous research showed that Wenu tidally interacted with the smaller of the two objects. Both lost some angular momentum by ejecting material and eventually merged to form today's Arakoth. The individual rocks look like Lego pieces and have similar sizes, compositions, and colors, all of which tell us something very important about the formation of Arakoth, Stern said during his presentation at the conference. Stern's team found that Arakoth's 12 rocks are more than 5 kilometers wide. Given that Wenu is only 10 kilometers thick, scientists think the 12 rocks clustered around Wenu's equator make up most of its body and extend to its far side, which New Horizons didn't see. However, the James Webb Space Telescope's first mission this year will be a program to study Pluto and some of the thousands of other celestial objects in the Kuiper Belt, a region of our solar system beyond the orbit of Neptune. These bodies, known as Kuiper Belt objects or trans-Neptunian objects, show remarkable diversity in terms of color, shape, size, groupings, clusters, pairs, and geological and atmospheric activity. While several spacecraft, including NASA's New Horizons mission, have flown past these bodies, they've only been able to observe them briefly. With Webb's sensitive infrared cameras, though, scientists will be able to study the objects over a longer period. Using Webb, we'll be able to get information about surface chemistry that might be able to give us some clues into why there are these different populations in the Kuiper Belt. Heidi Hamel, a Webb interdisciplinary scientist for solar system observations, said in a statement. Beyond that, scientists hope to analyze the data to learn about the solar system's formative years. These are objects that are in the graveyard of solar system formation, said Jonathan Lunine, an astronomer at Cornell University and a Webb interdisciplinary scientist. He noted that the objects likely had been around for billions of years and could last billions more. And Webb will also study objects known as centaurs, and we might be in for more surprises. What do you think the James Webb Telescope will discover next? Let us know in the comments section below.